at your normal Windows, Macintosh, Linux level, you're typically looking at what's called user land or user space, where you can interact with the operating system, you can run your applications, you can talk to hardware, your applications can talk to hardware, and well, the applications, I'm sorry, talk to the kernel, which then talks to the hardware. And that's really the difference, is that when you then migrate down, I'll say down, into the kernel space, now you're actually interacting directly with the RAM, right? Directly with memory, directly with the CPU, any peripherals that might be connected, like a USB key or, an external hard drive network, whatever. That's where the real core of the operating system is. So I think of kernel as the core. The kernel of the operating system is really the core capabilities of that operating system as it works with hardware and other different things. Your typical hacker, your typical, a lot of the things that we see are a lot of times in user space. So they're easier to find, they're easier to get rid of. Doesn't mean that it's simple, but it's easier once you find them to kind of remove them from user land. Much, much easier. When you have any piece of software that's running at the kernel level, you may not be able to even see that it's running, key number one, unless you have very advanced, either reverse engineering skills, or unless you're a kernel developer, you're not going to know how to look for different system calls within the kernel. That's just not your average skill set. At least for my customers, that's not their skill set. Yes, they can find things within user land, but that key distinction is that for, attacker or a defender, you want your agent, you want your piece of software to run in the kernel. Once you're in the kernel, it's harder to find you. It's definitely harder to remove you. And you can do basically anything you want at the kernel level. You're no longer relying on Windows or Macintosh or whatever to define what permissions you have on that computer. Once you're in the kernel, you write your own code and you can pretty much do anything you want.
Could you argue that you could live, if you had to choose between XDR and Audit D, is that a choice that, because people do make that choice, people choose just Audit D. If they had to choose, would you argue they should probably choose XDR?
I would for a couple of reasons, but I would also caveat it by saying that Audit D is great for certain things. And it depends on your use case, right? So for Audit D, and this is kind of a high level statement, but a lot of our customers use Audit D for compliance reasons. I guess they're trying to find bad stuff. Yep, that's a given. But Audit D is specifically written for audit records, right? Makes sense. So when you go back in time and you look at who accessed the computer, what time and from where and who did they talk to? Yeah, Audit D is going to provide that. But are you defending against anything with Audit D? Absolutely not. There's no prevention mechanisms within Audit D. It is simply a reporting mechanism. So with XDR, some of our customers put our software in just as a detect only type of mode where we are running in the kernel and we are detecting everything that comes in and out of that computer, like literally almost everything that comes in and out. And so if you're trying to defend that endpoint and not just be compliant, because those are two totally different mindsets, right? Then XDR is where you need to be. We also have the capability Elastic to be in full prevent mode. So typically what I like to do when I first install on a network for a customer is I like to be in detect everything at all times for any reason. And after, a week or 2 weeks or, whatever the right time period is, myself and the team, we can go back and then figure out with more preciseness exactly what we are looking to then prevent. That's the key difference. Audit D is reporting only. XDR is reporting, but also detection and prevention of threats.